Okay, so thank you for joining today. Our speaker is joining us right away. And next we have Victor Mania. Victor Mania, can you unmute yourself and introduce yourself and tell us about yourself?
Hello everyone, my name is Victor. I'm a software developer, and currently I'm looking for a job opportunity in Kenya. So, and alternatively, I'm a machine learning and Android enthusiast. So it's nice being here. Thank you.
Okay, thank you very much, Victor, for joining. So we have Elisa Chiku Ebuka. So can you tell us about yourself, unmute yourself and speak? And for those that just joined us, welcome to the second day of this boot camp. From next week, we'll be starting our ML Study Jams program. So, Olisa, let's hear from you.
Okay, thank you very much, Sir Victor. Um, I'm Olisa Martin Chukwubuka. Um, okay, I've been in mechanical engineering specialty, but recently I developed interest in robotics, seeing its potential in the industry. So let me say I've come to know about computer vision and machine learning. So I decided to develop my skill in it. So that's why I've been part of this platform to learn more about computer vision with machine learning and then knowing its potential application in the manufacturing industry and the like. So thank you very much.
I mean, that's really, really great. Thank you for joining. So, we have our speaker here already, and we are going straight to starting right away. So, before I call him to speak, let me give everybody a brief overview of today's session. So, how do we build AI systems? How do we train and test this model? So, praise Godwin, the CEO at Aorist Artificial Intelligence Lab, an AI startup based in Nairobi, Kenya, will be taking us on model training and testing. How do we actually train these models? How do we test these models before deploying them into production? So in this session, we will explore the critical processes involved in developing machine learning models, specifically focusing on the phases of model training and testing. You will also explain about you also explain how a model learns from data, the importance of selecting the right loss function, and strategies for avoiding overfitting. We will also delve into the significance of using validation and test sets to evaluate model performance, as well as how metrics like accuracy, precision, recall can guide us in model in improving model outcome. So today's topic is really, really great because there are a lot of machine learning engineers out there, and we cannot use all machine learning models. First, we have to test, we have to confirm that these models are actually very, very working. So I've said a lot of things about the model we'll be having today. So at this point, I would like to hand over to the CEO of Aorist Artificial Intelligence Labs to take over and continue the session as our speaker for today while we are still preparing for our machine learning bootcamp ML study jams next week. So thank you everybody. At this point, Mr. Praise, I'm super excited you joined the call. So you can continue the call and do well to turn on your camera so you can have a recording of you and your presentation. Thank you.
Okay. Uh, Good evening, guys.
Yeah, good evening.
And Victor. What time is it? At what time is it? How long should the session be? I just plan myself.
Okay, for 45 minutes to 1 hour is perfectly
Okay.
okay. Yeah, so
Can you see my screen?
yeah, I can see your
Okay.
screen, but
So
I can't see your
Yeah,
video.
we can see it.
Can't see your video.
uh, just a minute.
Okay, so we can utilize the chat section to ask questions and drop links to our social media handles, and as well connect to know each other in the chat section. Which the chat section, so if you have specific questions, contributions, do well to drop it in the chat section or in the WhatsApp group or even in the groups, so Google groups as well.
I'm having a hard time activating my camera. Let's continue. I'll just figure it out along the way so that we don't waste any more time. Um, so the topic for today was model training and model testing, right? And I'm not that much a fan of slides, so most part of the sessions we'll get our hands a bit dirty and get go hands on, if that's fine by you. So before we train our model, the first thing that we have to do is collect our data. And at times when we collect our data, we find that this data of ours, it's not good as it is. So we have to clean the data. So let's say, for example, mm, let's say, for example, you're training a model to that will identify apples in an image that has been provided. You'll need a data set of images of apples, and then maybe with the person who collected this data set at one point, there's an image there the images there that are not for apple, but they are in the data set. Now we'll have to clean this data set. Cleaning this data set is now removing those unwanted data that has made its way into the data set. The next thing that we will do is we will analyze our data set. When we analyze our data set, this is just basically trying to get insights from the data set, to know how the data set looks like, any relations in the data set, and to try now at this point when you're analyzing our data set, that is now when we will make our plots and all those types of all those types of visualization that you like to have. And then now from there on, we will now start our model training. Now for model training, we will split the data set into two. So preferably it's usually 80% of your data set is used for training, and then 20% is used for testing. So you'll divide your data set into these two categories: training and testing, so that after you have trained your model, you have actual data that you can test it with and confirm. If the model says that this is an apple, you already have the data that says that this is an apple, so you can cross check if this is an actual apple to evaluate the performance of your model. Once you have split the data set into two, the next thing that you're going to do is now you're going to choose an appropriate algorithm. And now you would like to train your data set, you would like to train your model. But now there are several algorithms that are there that can be used. There are several techniques. You can either choose to use reinforcement learning, supervised learning, unsupervised learning, linear regressions. You want to choose now which algorithm works best for you. Now you'll choose your algorithm based on the type of data set that you have. After that's why we did the data analysis to get insights. Once based on those insights, you can now choose the appropriate algorithm. But this process, you'll find that you'll choose an algorithm, train a model, and then you realize that this model is not as robust as you want it to be, or the accuracy of this model is not as good as it should be. And then you decide, maybe let me change the algorithm. Maybe you are using decision trees, and now you want to change the algorithm to random forest. Now, once you have done all that, once you have chosen an algorithm that you feel that is fit, now is where now we are going to now train the model on the prepared data on our training data set. So like an example, for our example, for image, for what do you call it? For apples, for classifying apples, we'll use the best model to use, the best model algorithm to use is a neural network. And then now you have trained your model. You have trained your model. The next thing that you have to do is now evaluate your model. Now this is now the model testing part, because now you need to before you deploy your model, you have to make sure that it is as accurate as possible. The accuracy of the model depends with the use cases. The areas where an accuracy of 97 to 99% is needed, but there are areas where a 60% accuracy is acceptable. So based on what you're trying to do, let's say for like you're doing a model that detects cancerous cells. In this case now, we need a high accuracy, because this is now a high risk model, that technology that you're now building, that if it messes up, someone might die. Or let's say just in the medical field, you've made this AI that can, you're making this AI model that can perform operations on people automatically. Now it's using computer vision. The precision that is needed here is very high. So you have to have a high precision rate for your model. But let's say, for example, you're making a model that you want to go and use it to go and deploy to trade in forex. Hmm. For forex, an accuracy of even 60% is acceptable, because with an accuracy of 60%, you are making more money than you're losing. And for forex, the aim is just to make money. So now, for accuracy of your model, that one now will depend on the specific use case and the risk associated with it. Then, when you're evaluating your model, you'll be evaluating it based on your test dataset. Remember earlier we had split our dataset into training dataset and testing dataset. After you have trained your model, you test it now with the test dataset, and then we will see how we can evaluate the performance in a few. And then the next, once you are now confident that I am comfortable with the accuracy that my model has, and you now want to deploy it. Now, when you want to deploy it, there are several ways that you can deploy it, but that is not for our discussion for today. Just to give you an overview, you can either create a web application, like a backend service that that users can use to interact with their model, because your users are not techies who can interact with their model either from Jupyter Notebook or Google Colab or the terminal. They want to have a nice user interface that they can use. So for that, you will have to deploy your model to a production environment. You can use serverless functions. There are providers such as Cloudflare that allows you to write serverless functions and expose your models on the go. You can check them out. Or most of the serious cloud providers like AWS and Azure also have serverless functions that you can use. But that is a topic for another day. Now, it's now time to get our hands dirty. Can you see my screen?
Yeah, sure. Though they are tiny.
Okay. Oh, let me. That's fine.
Yeah, don't worry, I can zoom it from here.
What?
Yeah. Uh, Now you can see my screen well. It's visible.
Yeah, I can.
Okay. Okay. So this is just a simple project that we are going to use today. Yes, I will make this material, not the slide, the Google Colab available. I'll share it with you after the session has ended. Um, yeah. So this is a simple project that uh, you, the aim was to create a machine learning model that can do forex trading, focused on trading currencies, that is euros and USD. And we are getting our data sets from Yahoo. Yahoo stores the forex data. They've been storing it from, I think, 2003. every day they update their data set, so they have uh, a very good robust data set for uh, forex. If you need data sets for forex, you can get them from Yahoo. So the first thing that you are going to do is to install the libraries that we will require, um, and we'll be using Google Colab. Just give it time so that it connects to a runtime. That's connected to a runtime. Run, huh? If you have any question, you can just always raise your hand and ask. Ama, you can, if it is not so pressing, at the end of the session, there will be, I'll take some questions from the audience. So after installing the necessary requirements that we need, we are going to get our dataset from Yahoo Finance. They have a library, a package known as Y Finance that can help you instead of going to download the dataset manually from their site. You can just automate everything through their package, the Python package. So we are going to get our data, and these are just the imports that date time, numpy, pandas, those are we'll use for data analytics, and then seaboard and matplotlib for data visualization to visualize our data set. So this is a data.head to see how an overview of our data. So this is how the data set that we have looks like: open, high, low, close, adjacent, close. Yeah, basically. So the data set, Yahoo started collecting the data set in 2003, December. Yeah. So the first thing that we are going to do, we talked about cleaning our data sets. Yeah. There were certain data. There are certain data in our data set that we don't really need. So we'll get rid of those. And do some visualization. So this is just a bit of visualizing the. We had a. Let me just create a new cell. Yeah, just create a new cell. Do df head. This is how our data set looks like, and this is just a bit of visualization on the adjacent closed column. This column. So the next thing that we're going to do, we need to look at the adjacent closed column. That is the column that we are very interested in much throughout the entire project. So we are going to do a visualization on it so that we can just get an overview of how the data looked like. So the next thing after we have done that, now we are going to make our training data set that we will use to train our model. So basically, this is just an overview of our data set, the shape of our data set. So we have 5,335 rows. And then the next thing that we're going to do is, you remember we talked about dividing our data set into training data set and testing data sets. In this case, now I've divided the data set into two, but the training data set I've used 95% of the total data set for training. And then the remaining is what will be used for testing. Okay, so there's something that now we are going to use a gradient boost classifier to train our model. That is the algorithm that now we are going to use. Random state is the random and the gradient boost classifier. The random state is just to tell the algorithm or to tell your Google Colab that do you want your data set to be taken at random? At times, it's good to randomize your data set, but due to the nature of our data that we are dealing with Forex data set, we don't want it to be randomized, because if we randomize it, our accuracy score will be very low. So this is going to take a lot of time. Just a minute. Let us utilize the GPU. Because this sklan cannot use the GPU, cannot access your GPUs, and if you try later on, once you're done during the open session, I'll come back and run this cell so that you can see how long it will take. It will takes like 15 minutes, and with the GPU you can reduce that time to almost close to zero. So let's have a learning rate of 0.03. Yeah. Then we can print. We can do some printing to get our accuracy, to print the accuracy score and the CLF score. So instead of using sklearn, the gradient boost classifier from sklearn library, we are going to use xgboost instead. So just run our code. Yeah. You see now, let me just rerun it again. Like what was there. Yeah. So you see the execution time for this cell is 22 seconds. Just note that down somewhere. We will come back to that number. While using the GPU, the execution time is 22 seconds. And on the testing accuracy, we have achieved an accuracy of 0.5243. That is 52% accuracy. So now, when you are building your model, you find that things like the learning rate and the number of estimators, you'll always, when you to achieve high accuracy, you'll have to tweak these things, the values, and that now we use 0.03. We can always tweak it. So when I was doing this, I said, let me try and give the model several learning rates and loop through those learning rates so as to come up with the ideal learning rate that can be used to train the data, to train our model. So that is basically the use of this cell. And, can just run it. So you see, and this one is just a loop, so it will loop through the different learning rates, and it will tell us the accuracy that we have achieved by tweaking, by having the learning rate of 0.001. You see the list that we have here. This is the list that has the different learning rates that we are looping through to find to see the performance of the algorithm on the model training while training our model. So it will just loop through all those learning rates that are given in the list, in the previous list. When you'll be building a model, you'll also have to do those tasks. And now that is why when you're doing machine learning, if you understand data structures well, these loops can really come in handy, either when training your model to find the ideal testing, the ideal learning rate or the number of estimators, or to find the ideal algorithm. You can create a loop that just checks the best algorithm so that you can now know which is the best algorithm for that will achieve the highest accuracy score based on your model. This will take some time because there are several learning rates that are there in the list around. I think there are about slightly more than 10 or more than 15. Let's just give it time. Anyone who has a question as we wait for the cell to complete running? Ama hakuna swali? Ama there's no question? Okay, let us continue. Maybe we'll have questions at the end of the session. Uh, hmm. So after we build our model, we will the next thing that we need to do is now to test our model on actual data that we already know. So for the example that we're using right now, we are using a forex data set. What we need to do, what we will do next, we will do when testing our data, we will hide part of that data from the test data, and now ask it to make a prediction of how the let me call it the graph of how the currency's valuation will fluctuate, and make a prediction on when to buy and sell, and see if its prediction was right, or the model was not accurate. So, like for example, I don't know how many of you have ever, not how many of you, I believe everyone has used ChatGPT at one point, even this week. At what point this week, at least you have all. I want to believe that we have all used ChatGPT, me included. And at times you ask ChatGPT a question, and it tells you a very ridiculous answer that you wonder where it has come up with that answer. And these ridiculous answers that ChatGPT might give you in machine learning, they're called hallucinations. Your model is hallucinating. That now the machine learning community or the computer science community do not have an exact reason of why neural networks work the way they work, why they might give wrong answers. Wrong answers. They don't have. They don't have, but there have been recent studies by a company known as Anthropic, the company that builds cloud AI, and they're trying to understand why hallucinations work.
Oh, okay. Um, so while we are waiting for our speaker to rejoin the call, I think he has technical issues or a little bit of concern for the to complete the session today. So far, do we have any question as regards to the session we just had, or any contribution?
Uh, Sorry, guys.
Okay, he's back. I mean, thank you.
I had a slight issue with my internet.
Network.
Yeah.
Sure. Okay.
Uh, you can let me just reshare the screen.
Mm,
Can you see my screen?
yeah, I can see your screen.
Okay. So you can see my screen. That's good. So after once we have once we are done with now let us look at the you see now based on the loop that we had, we can see the effect of the learning rate on the accuracy of the model, and we can see that the highest accuracy was achieved when the learning rate was 0.008. Now we can now build our model because we know that now the ideal learning rate 0.08. Uh, we can now train our model knowing with that data now. Let's give it time. Uh, Now after we have trained our data set, let us see. Yeah, we have achieved an accuracy of 0.56. Now we have trained our model. Now the next thing that we need to do is to test our model to test if our model is working the way it's supposed to work, and if, for example, for now since it's a forex model used for trading in forex. Oh, Abdul, I've seen someone raise
Yes,
their hand.
please. I'm going to I have a question, please.
Okay.
Yeah, thank you very much. You were talking about hallucination. Please, how do we know that our model is actually hallucinating? Then is
Uh,
it only artificial neural network that hallucinates? Then how can we stop the hallucination? Thank you very much.
I haven't gotten you clearly. Can you type your question in the in-call messages? I think that will be better because your audio wasn't that clear. Okay, let's wait. Abdul, you can just type your question in the in-call messages. Uh, um, Let me answer that question at the end of the session. We are almost done, and then I get back to you. So let us now test our model to see if it's going to make us money, or are we going to get a loss. So uh, for the test, I gave the machine learning model, uh, a demo $50,000 initial capital for it to trade. And then now let us now print and see if our model has made us money. So based on the accuracy, since we had an accuracy of 56%, our model has made us a profit from the $50,000 that we gave it. The model has achieved to give us a profit of $3,571 in with 149 of the trades being winning trades and the losing trades being 116. And the largest winning trade being $616 and the largest losing trade being $882. The average winning trade is $146. The average loss rate is $157. So basically, you see with our model having, however, despite our model having a very low accuracy of 56%, but since the use case is in Forex, the model is still able to give us profits. And the main aim of this model now is to make you money. As long as it is making you money, the model is doing what it's supposed to do. Ever much it at certain times it is losing. It is losing you money, but the overall money that it makes you is more than the money that it loses. So it's acceptable. So now at this moment, can welcome any question. And let me first start with the question that was asked by Abdul. And the question was why do models hallucinate and how we can stop hallucination. So hallucination in general it's something that happens when learning models. It's common among LLMs, large language models, when they generate an output that is incorrect or one that doesn't make sense or one that is not real. Uh, in Kenya we will say imetema jaba, but that is so the causes of hallucination. It's not only in ANNs that our models that hallucinations happen. It's common in neural networks. Majorly, the convolutional neural networks also have it, also as ANNs. And for the normal, for the common algorithms that we can use, the common algorithms that we use, the issue might arise from either overfitting or underfitting of our data. And it happens when the model extrapolates from the prompt or the training data. I think I've answered your question. Any other question?
Okay. Sorry. Thank you very much for the wonderful session today. I mean, I've really learned a lot on about training models and deploying and testing this model. Sorry. So, the question that was asked in the chat session has been answered. I don't know if there is any other question, or do we have any other question to ask? You can indicate as well so that you can have the opportunity to speak. And at the meantime, I'm going to say more about our community for our new community members. We will need speakers for our next session. And on Monday, we are starting ML Study Jam. ML Study Jam is a virtual program designed to run for a month on Wednesdays, on Monday, Tuesdays, and Thursdays. So do well to make sure you join the group so you don't miss out on any information. In the absence of any other question, thank you all for joining. Do well to share the flyer, and we will have our next session with starting with our speaker Sarah on Monday on introduction to AI, deep learning, convolutional neural network, and the rest of it. So if you are not in the any of our groups, I have pinned the chats, I've pinned the links to our groups here. So do well to join us, and thank you all for joining. Thank you for speaker. Thank you very much, Mr. Prince. Thank you.
Okay.
All right. Bye everybody.
Before we leave, I've also shared a
Okay, the
link
link
to
to the
the.
slides. Okay, let me copy it.
Okay.
Okay, thank you.